Let us begin by understanding the meaning of sampling. Sampling is a process of choosing a representative sample from a target population and collecting data from that sample in order to understand something about the entire population. But in order to make an assessment of population parameter of our interest, we can interview each and every member of the population. For example, in order to assess per capita income of people living in a particular community, we can interview each and every member of that population, that is all the residents of that particular community, about their income. This method is called complete enumeration or short census method, and this can be very time consuming and resource using. A method which is manageable and less resource consuming is to take a sample from the entire population and calculate an estimator of the population parameter. Taking a sample out of the population to calculate an estimator may lead to bias in calculating the estimate. Hence, to avoid this bias, we aim to take a representative sample of the entire population. This module takes a tour of two kinds of sample designs. The designs of a sample refers to the methods used to choose a sample from the entire population. There are two kinds of sample designs. First, that's a random sampling. In this design of sample, we have the chance to choose a sample. The sample is chosen by chance with prior information available on what samples can be chosen and what are the probabilities of each sample getting chosen. Every item of the population here has a known chance of getting selected for the sample.
After starting this module, you shall be able to know the methods of random and non-random sampling. Learn the conditions under which techniques of random and non-random sampling can be applied. Identify the conditions under which each technique within random sampling and non-random sampling can be applied. Evaluate the comparative benefits of each type of sampling techniques. Let us discuss the properties of random sampling technique, which are as follows. Distinct samples from the population can be defined. Each sample is selected randomly with equal probability of getting selected. The method for computing the estimate from the sample must be stated and lead to unique estimates for a specific sample. With the use of sampling theory and the assumption of normal distribution, these methods also enable calculation and prediction of amount of error expected from the estimates of the population parameter.
The method of computing the estimate from the sample must be stated and lead to unique estimates for a specific sample. So for example, it can be stated that the estimate is the average of the measurements of the individual items from the sample. This sampling procedure is amenable to the calculation of frequency distribution of estimates for each sample with repeated sampling undertaken. We know the number of times a particular sample will be selected and thereafter the estimate from that sample is calculated. Thus, a well-defined sampling theory can be developed for all these procedures. Also, for this procedure, it was realized that by the use of sampling theory and normal distribution, the amount of error to be expected in the estimates made from the sample can be approximately predicted. There are various ways to obtain samples that represent the population.
There are various ways to obtain samples that represent the population. Some of the methods of random sampling are the following: simple random sampling, systematic random sampling, stratified random sampling, multi-stage random sampling, cluster sampling, and probability proportional to size, that is PPS sampling. Let us start with simple random sampling. It is a method in which each of the samples chosen has equal probability of getting selected. In other terms, the random variable x1, x2, so on till xn are said to form a simple random sample of size n if the following two conditions are met. A. The xi's are independent random variables. B. every xi has equal probability. If the random variable satisfies these two conditions, it is termed as independent and identically distributed. There are various ways by which we obtain random samples. One is the lottery method, in which individual units of the population are allotted a number, which are then put onto slips of paper. These slips are then shuffled and a random draw of required numbers, which constitute the sample size, is done. This constitutes a random sample. The other method is that of using random sampling numbers. The most important virtue of this sampling method is that it is easiest to derive a probability distribution of the sample statistic than for any other sampling method.
In simple random sampling, each xi of the sample has equal probability of p equated to n upon capital N. Here, all the units of the sample are selected using a random mechanism. For example, a national fast food chain wants to randomly select 5 out of 50 states to estimate the taste for its consumers. A simple random sample will ensure that samples of size 5 which have the same likelihood of being used in the study.
The method is used when the population units are homogeneous and ordered in a random fashion and not in pattern. In systematic sampling, the sampling units are selected at equal distances from each other in the frame, with random selection of only the first unit. A sampling interval is calculated by dividing the population size by the desired sample size. For example, a university has 100 students, and a systematic random sample of 5 students is to be taken. A sampling interval is calculated by dividing 100 by 5, which equals 20. Then, all the students are ordered in a sequential number. The first student is selected at random from 1 to 20. Say the second student is selected, and thereafter every 20th student is selected. For example, we first select the second student randomly and then every 20th student like 22, 42, 62, and 82. Both simple random sampling and systematic sampling techniques are usually recommended when all the population units are relatively homogeneous.
It is useful when population units are ordered or listed in a random fashion. For example, in case where houses are randomly arranged in rows, suppose a few houses at random are to be selected from a given city. Here, systematic sampling can be used because the houses are usually arranged either in rows or in columns and are thus numbered. The first house is selected at random and the next 10th or 15th house is selected systematically. In systematic sampling, the sampling units are selected at equal distances from each other in the frame with random selection of only the first unit. Another population in which systematic sampling is used is when the selecting items from the production or assembly line of quality testing is undertaken. A manufacturer may select the first item, after which every 20th item is selected from the sample.
Stratified random sampling technique is adopted when the population from which a sample has to be drawn is heterogeneous. To draw a sample from heterogeneous population, we first divide the population into homogeneous groups called strata and then draw random samples from each stratum. The heterogeneous groups or subpopulations must be non-overlapping and adding up all the units of the strata must give us the total number of units of the population. We can use one of the two approaches. Either we select at random from each stratum a specified number of elements corresponding to the population of the stratum in the population as a whole. Another approach is to draw an equal number of elements from each stratum and give weight to the results according to the stratum's proportion of total population.
In other words, Stratified sampling divides the population of n units into subpopulation of n1, n2 going till nn units. These subpopulations are no overlapping and together they entirely form whole population, so that n1 plus n2 plus nn equated to capital N gives us the population. The subpopulations are called strata. A random sample is then drawn from each stratum, the drawings being made independently in different strata. The sample sizes within the strata are denoted by small n1, n2 going till small nn. We can use one of these two approaches. Either we select at random from each stratum a specified number of elements corresponding to the proportion of stratum in the population as a whole, or we draw an equal number of elements from each stratum and give weight to the resultants according to the stratum proportion of the total population. With either approach, stratified sampling guarantees that every element in the population has a chance of being selected. For example, in order to select a sample of 10 joinees from a population of 100 joinees, where there are 4 locations, we have north, east and west and south, with the proportions of north being 40%, east being 10% and west being 20%, south 30%, the sample can be selected as 4 from north, 1 from east, 2 from west and 3 from south, or select equal samples from all the states and give weights to each sample. The sample will be selected in such manner and in case of any random sampling techniques described above. This procedure is described as stratified random sampling. This stratified random sampling can be used for various reasons. Some of these reasons are: first, administrative convenience that may facilitate the use of stratification itself. For example, the agency conducting the survey may have field officers in different geographical locations. Each of these can supervise the survey for a part of the entire population. Second, sampling problems differ significantly for different parts of population. For example, people living in institutions, for example hotels, hospitals, prisons, they are often placed in a different stratum from people living in ordinary homes because a different approach to sampling is appropriate for the two situations. Populations of people can be divided into different strata of income groups, for example high income groups, low income groups, middle income groups, and this can greatly enhance the analytical capacity of the sample statistic. Third, stratification may enhance the precision in the estimation of characteristics as compared to the simple random sampling of the entire population by dividing the population into heterogeneous groups or subpopulations. Each of these is internally homogeneous. The estimates of each strata can be combined into precise estimates for the entire population.
Let us understand multi-stage sampling with the help of an example. Suppose we have to estimate the per acre yield of wheat in Punjab. We might obtain the entire list of villages in Punjab and select a given number of villages at random according to random sampling procedure. Then, from out of the selected villages, we might select a given number of fields at random. This is a two-stage random sampling procedure. In another situation, one might first select some districts at random, then from out of the selected districts, select a given number of villages at random, and then finally select a few plots on the selected fields. This procedure is called multi-stage random sampling procedure. Cluster sampling is a sampling survey in which the sampling unit consists of groups or clusters of small units called elements. It is used in the following scenarios. A. Cases in which a reliable list of individual elements in the population might not be available, and it can be prohibitively expensive to construct such a list. B. Cases in which population units are widely distributed in any large geographic region or natural clusters. For example, we want to estimate health insurance coverage in a city having 200 blocks. Out of these, we can select, say, 5 blocks and from each block interview 20 households. This implies that a listing frame of only 5 blocks needs to be prepared, which means that less time and cost will be required. The blocks are called the primary sampling units or clusters. The households are called secondary sampling units.
Another example is that of taking a sample of children in an elementary school. We could take a simple random sample. An alternative is to form random samples of classes and then measure all students in those selected classes. It should be noted that cluster sampling is different from stratified random sampling, and while stratified random sampling, a random sample is taken from each of the stratum, cluster sampling treats each cluster as a sampling unit, and hence all the observations in the selected clusters gets included in the sample. Every cluster unit may contain same number of elements. However, cluster units may also contain different number of elements.
Probability proportional to size, that is PPS sampling, is a kind of cluster sampling in which the probability that a sampling unit gets selected in the sample depends on the size of the population of the sampling unit, giving large clusters, that is those having larger population, a higher probability of getting selected than smaller clusters. It is useful when the sampling units vary considerably in size because it assures that those in larger sites have the same probability of getting into the sample as those in smaller sites and vice versa. Not all the items of the population have a known chance of getting selected to the sample. There is a high chance of selecting biased samples by this method, which does not represent the population. Methods by which we can take a non-random sample are as follows: quota sampling, convenience sampling, volunteering sampling, purposive sampling. Let us start with quota sampling. It is similar to stratified sampling, with the difference being that the selection from a particular stratum is non-random. The quota of a particular stratum is fixed by the researcher, independent of the proportions of that strata in the population. For example, in a study of views of minorities on death penalty for the state of Punjab, a random sample of people will for sure miss the Muslims, since there are not many Muslims in that state. To ensure their inclusion in the sample, a fixed 1% quota in the sample is fixed by the researcher, even though it is not representative of the population. The quota, however, serves to make comparisons across all the minority communities. Another form of non-random sampling is convenience sampling. Under this technique, the samples are selected according to the convenience in terms of accessibility and proximity to the researcher. This method does not produce representative sample. For example, from a class of 50 students, 7 students need to be selected. So the researcher selected first 7 students from the list. Volunteer sampling is a method in which the people who are a part of the sampling are volunteers who participate in a particular sample survey. There is as such no design of the sample. For example, a radio station may ask its audience to give their opinion on a certain issue, with only two possible opinions, yes or no. A mobile phone number is offered to the audience for a SMS facility of Y for yes and N for no. A time period is offered to the audience to text their opinion, after which the phone number facility is closed. And it's on this basis that a conclusion is formed. Purposive sampling, also known as judgmental sampling, is a method in which the sampling units are so selected as to meet the broad objective of the survey by taking a sample that represents the control variables of the study and for which the results of the entire population are already known. The method requires prior information of the characteristics of the sampling units before being selected as an item of the sample. Hence, a huge amount of discretion and judgment on the part of the sampler is required. An example of purposive sampling is the following. To determine the overall performance, that includes academic and other pursuits, of average student of a particular grade, we shall take a sample of 10 students out of the 100 students of that grade, such that they are just average. The control variable here is their marks and its possible correlation with other variables of overall performance like sports, arts, music, etc. It also requires prior information on the part of the researcher about the sampling unit, the students in this case.
The method requires prior information of characteristics of sampling units before being selected as an item of the sample. Hence, a huge amount of discretion and judgment on the part of the sampler is a must. This is unlike the methods of other random sampling, in which each sampling unit is seen as interchangeable. There are different kinds of purposive samples. For example, maximum variation sampling, homogeneous sampling, typical case sampling, extreme case sampling, critical case sampling, expert sampling. All these sampling methods define the control variable. For example, expert sampling would omit amateurs, typical case sampling would exclude outliers from the sampling, etc.
In this module, you have learned about two types of sampling methods. Random sampling, in which each sample is selected randomly with equal probability of getting selected, and non-random sampling, in which all the samples do not have equal chance of getting selected. You have also learned about the characteristics of different methods of collecting data within random sampling, like simple random sampling, systematic, stratified, cluster, multi-stage, and non-random sampling like quota sampling, convenience sampling, volunteering sampling, and purposive sampling.
Let us now summarize what we have learnt in this module. Distinct samples from the population can be defined. Each sample has a known chance of getting selected. Each sample is selected randomly with equal or unequal probability of getting selected. This procedure is amenable to calculation of frequency distribution of the estimates, and hence a well-defined sampling theory can be developed for all such procedures. With the use of sampling theory and the assumption of normal distribution, these methods also enable calculation and prediction of amount of error expected from the estimates of population parameters. There are many methods that can be employed to assure that a sample is chosen to randomness. Simple random sampling, systematic sampling, stratified sampling, cluster sampling, multi-stage sampling, and PPS sampling are some of the methods to ensure random samples. Each method is relevant to different population kinds. On the other hand, non-random samples, they have the following features. It is a sampling methodology in which all items do not have a known chance of getting selected. In fact, some items have zero probability of getting selected. There is a high chance of selecting biased samples in this method, which does not represent the population at all. There are number of methods by which we can take a non-random sample from, some of which includes like quota sampling, convenience sampling, volunteer sampling, and purposive sampling.